All right. I'm Brian Holmes, project manager at BAM. I suppose we tendered the HBB project. I'll call it it's human biology building, but a HBB project. We tendered it in 2014, and we started on site first thing back in January in 2015. But just I suppose the project was initially designed back in 2008. I suppose certain reasons may mean it had been shelved for a number of years. I suppose economic being one. But I suppose that was one of the challenges. A building designed back in 2008, obviously certain regulations and certain items change from over a period of time. And I suppose we had to work with Paul and work with the design team to develop the design to ensure it complies with the current standards that we have to work to today. I suppose one big challenge with the project is the centre of campus project from a construction point of view. I have a small little brief animation video that I'll show to you there. It's about 2 or 3 minutes long. I suppose it'll give you an idea of the phase and how the building was constructed. Just to note on it, some of the timelines, because it was tendered back in 14 and we didn't start until 15. The timelines, I suppose, just don't heed the timelines, but just you can have a quick look at that. So that's the site there. Obviously, the enabling works was done before we started on site. Just a note there, we have a bit of enabling works to allow the realignment of the road to give us the full footprint of the building, just to keep that in mind. It was just to note that this is probably where the current stage is, where we are at the moment on site. Okay, so I suppose that gives you a quick introduction to the sequence of how we felt we were going to construct it, and how in fact it turned out that we did construct it. And I suppose 3D models give us a good idea and a good perspective on how things are going to function and how they'll operate on site. I suppose just a quick project overview. Paul said there that the enabling works have been completed. I suppose this was a huge advantage because obviously the enabling works involved a huge amount of rock breaking. I think the enabling works tender went out to take advantage of the summer period in the college. Obviously, it's a huge noise, huge invasive works. So I suppose the local residents and the college it was least disruptive. So that was completed before we arrived on site. I suppose one thing we noted when we were initially tendering the job was the basement, it was a hole in the ground and it was left that way for approximately a year before we started on site, but that the water table level was quite high in it, and this was clearly evident by going into site. I think we calculated the water table level was at about 1.5 metres above finished floor level. So I suppose we had to take recognition of this when we were tendering the job, because obviously the basement had to be waterproofed, and I suppose I'll touch on that a bit after. There's 4 floors above ground, mixed use, and a plant room on top of that again. There's a circulation and atrium area, there's teaching areas, there's laboratory areas, and there's office areas. So it's a high, Paul has gone through it already, but a high mixed use building. The basement is a testing facility. I suppose just before I go on to that, I suppose just we have to take account that obviously the basement is a testing facility, and I suppose we'll touch on this just a small bit after, but we have to take recognition of workmanship around the basement. Project constraints that we encountered, I suppose we all talked about the canal. There's an existing canal there, and it's classified under an EU directive as a special area conservation. And that is because it is a tributary of the River Corrib, and that's why it got its classification. So I suppose when we arrived on site, the basement was 1.5 metres above finished floor level, probably about 2 metres of water covering the whole footprint of the site. We had a huge amount of water there, firstly, that we had to discharge off site before we could even start our works. We can't just pump it into the canal. The canal is deemed a special area conservation. So I suppose we engage with all the regulatory authorities, and we engage with them closely and came up with the solution that we would actually discharge the surface water into foul, and we agreed this with the local authority. And I suppose this mitigated against the risk of us polluting the canal and potentially polluting the River Corrib. And the second obstacle we came across there was actually an invasive weed on the site called Japanese knotweed, and I suppose it's becoming more relevant in more recent years. You'll see it along water courses, you'll see it along roadways, and you have to receive a license from the Department of Arts, Culture and the Gaelic to remove it. And I suppose that was one challenge, and it has structural implications in porous concrete. The roots go into the concrete, they expand, and they can actually in fact crack concrete. So that's something we had to get a license from the Department of Arts, Culture and the Gaelic, we had to remove it and get a license and a certificate of clearance. Similar procedures in place to remove an asbestos, in fact. So they were 2 constraints that we met, and another one was obviously the big elephant in the room. We're large, where the site is based here, and Paul talked about it here. This is the main thoroughfare. The hoarding was set up when we arrived on site because the enabling works were complete. But this is the main thoroughfare for the college. It actually used to pass through here, but this was hoarded off. So the natural route for pedestrians was that they were coming around here, coming down here, and going to the college bar on that side, and that we had a natural boundary of an SAC canal on this side. So I suppose this influenced some of our choices of products and some of the decisions we made on the project. I suppose there's a huge risk there. And when we were tendering the project, we had to take account of that. The amount of deliveries we bring to site, the amount of disruption that we can bring to the campus without affecting the campus and the way the campus operates. So I suppose they're 2 of the constraints. When I move on, I suppose you'll see why we moved and made some of the decisions we made. I suppose in our design development, and the design didn't limit it to in-situ concrete, but we had a previous experience of using precast concrete, and I suppose we found this a huge advantage. One, going back to the fact that we were in a live university campus. If we were pouring in-situ concrete, we had large amounts of concrete deliveries, pumps to be set up on a confined site. We hadn't the room to do this, and I suppose a cleaner environment, cleaner site when we're using precast, and taking into account that we're beside a canal that's a special area conservation and the implication of polluting that if it did happen. So I suppose we went ahead with precast, and I suppose the advantages to us on this job with precast was we had a reduced number of deliveries. Orden Precast was the precast manufacturer for this project. They take the initial design, they develop the design, and they come up with the proposal. We propose this to our design team, our ER, and the technical advisor team for the job. I suppose the advantages for all was reduced deliveries. We had an enhanced finish, a factory-controlled finish on the precast. We had improved program implications. You might have seen on the animation there, we were shown finishing in July, well, we'll probably run into August. But with in situ, we're saving about 3 to 4 months with the use of precast. I think roughly on site we were achieving a floor every 2 weeks. We wouldn't achieve that with in situ concrete. We had reduced waste, which was a huge thing from concrete wastage. We had obviously one thing we've encountered is that using in situ concrete, there's a huge amount of waste. We had an improved environmental statistics because we could get the statistics from more precast and the reduced waste, and we had an improved finish. Disadvantage, I suppose, with using precast is it's an increased cost, and we pay a premium for that, but we feel to think that it reduces our prelim, so potentially it might work out cost neutral at the end of the day. And a disadvantage, although be a disadvantage or an advantage, we had to have the early coordination of services because we had to ensure that our ropes were in the right location. Second thing there was obviously we talked about the basement and the importance of the basement and the laboratory and the testing that involved in the basement. We went away from the standard pre-proofing, and we had used this product. It's called a Roscar, it's an injectable water bar system, and we found it a success in previous projects. And I've worked with it myself on previous projects. I suppose the advantage of using this system was it was insurance backed and an insurance backed warranty. So if the basement leaks, doesn't matter what caused it, we won't say it was done by one or it was done by the other. Because it's insurance backed, Roscar backed by Zurich Insurance will fix the error or the problem or the leak no matter who caused it. And this is insurance backed for 15 years. So the college has a huge advantage in using this system. There's a reduced risk, as I talked. Quality control, Roscar on site to install this system and install the injectable, and they monitor that. Increased productivity because of the restrictions on pores. Using Roscar system, you can pour the whole basement slab in one pour if you want it, because they use a system of crack inducers. The disadvantage is increased cost, and secondly, if you have a design team that hasn't used it previously, getting the design team's buy-in. I'll finish up on this, but just so you know the system, you'll see there, you pour the basement slab, you put in this channel before you place your wall. That is then injected once the concrete reaches this 28-day or full structural strength. To increase the size of the pores, we use what's called a crack inducer. When all the concrete has gone off, you'll see these yellow, it's a spongy type material. The company come and inject it. And to be honest, in my experience, I've done a swimming pool with it. It's passed the drop test first time. So it has a 100% success rate with myself, and hopefully on this job it'll have a 100% success rate also. So I think that's me. Right.